In the given question, it is mentioned about a body resting on a rough horizontal plane, and it requires a pull of 18 kilonewton inclined at 30 degrees to the plane just to move it. It is found that a push of 22 kilonewton inclined at 30 degrees to the plane just move the body. So we are required to determine the weight of the body and coefficient of friction. So this body is subjected to two kind of forces. One is the pull and one is the push. Based on these scenarios, we are required to calculate what is the weight of the body and what is the coefficient of friction between the horizontal surface and the body. So let me just draw the diagram here. So this is a case where we will consider 18 kilonewton of pull, and in the second case we would be considering 22 kilonewton of push. So let's take a case number one. So when P is equal to 18 kilonewton and theta here is 30 degrees. So let's say the force P is acting like this. It is passing through the center of the block and it is making an angle of 30 degrees with respect to horizontal. This is P and it is a pull force we are considering. So now if we consider the equilibrium conditions, so first is that we need to mark the forces what are being present. First is the most easiest one, that is the weight of the block which is acting vertically down, and exactly opposite to the weight there will be one more force that is going to be vertically upward, and that we call it as normal reaction. So this normal reaction would be collinear with the weight of the block, and along with it the along with normal reaction there will be one more force that is going to accompany, that is the tangential force or friction force at the interface of block and the ground. Let's call it as F and let's call it as Rn. So now we need to consider the equilibrium of forces. So first is that equilibrium of forces in x direction, that is P cos 30 is equal to F, and this is equal to mu times of Rn. So here P is given as 18 kilonewtons. 18 cos 30 divided by mu is equal to Rn. This would be Rn value. Same way, let us consider the equilibrium of forces in y direction, sigma Fy equal to 0, and that is Rn minus W plus P sine 30 is equal to 0. So we would be getting this as Rn is 18 cos 30 by mu, and P is 18 sine 30. So we can write here W is equal to, that is P sine 30 is 18 sine 30 plus Rn is 18 cos 30 by mu. So let me just, here I need to rewrite, mu is in the denominator of only 18 cos 30. So this would be equation 1. Now let's take another case, that is case 2. The force P is taken as push of 22 kilonewtons. So now the weight is going to act downwards. Same weight will be there and normal reaction will also be there along with it. So the force applied here is the push, which means the force is pointing towards left hand side. So this would be the push that has been applied on the body, and the push is going to make an angle of 30 degrees with the horizontal. So here P is equal to 22 kilonewtons. And one more additional force that will be present is at the interface of block and the ground, that is friction force. So in the case 2, sigma Fy, or let's start with sigma Fx equal to 0, that is minus 22 cos 25, cos 30 it is, cos 30, minus 22 cos 30 plus friction force equal to 0, minus 22 cos 30 plus mu times of Rn is equal to 0. So Rn here is equal to 22 cos 30 divided by mu. This was the equilibrium of forces in the x direction. Now let us write for y. Sigma Fy equal to 0, that is Rn minus P sine 30 minus W is equal to 0. So Rn we have written it as 22 cos 30 divided by mu, and P is 22 sine 30 is equal to W. This would be equation 2. So now we have got two equations in terms of W equal to something into mu, and in the equation 1 we are writing the same thing as well as in equation 2. So once we equate equation 1 and 2, we would be getting, that is upon equating 1 equal to 2. So we would be writing this as 18 sine 30 plus 18 cos 30 by mu is equal to minus or 22 cos 30 by mu minus 22 sine 30. So now here we need to club the terms on one side, and on the left side we would be getting 22 sine 30 plus 18 sine 30 is 40 sine 30, and 40 sine 30 is 20 because sine 30 is 1 by 2, and 18 cos 30 will shift to this side, and this becomes 22 minus 18 cos 30, which is 4 cos 30 is equal to mu, and this is 4 ones are, and this would be 4 fives 20. So mu here will be equal to 1 by 5 times of cos 30. 1 by 5 is 0.2 and cos 30 is root 3 by 2, or which is 0.866. So 0.2 into 0.866 will be approximately 0.173. That would be coefficient of friction. And now if we substitute mu in the equation, we would be getting W as 22 cos 30 divided by 0.173 minus 22 sine 30, and this will give us W equal to 99.3 kilonewtons. That would be the weight of the object.